Section 15 of The Challenge of Waste by Stuart Chase. This LibriVox recording is in the public domain. Recorded by the Progressing America Project. The Challenge of Waste, Section 15. Wastes in the Technical Process. We have already pointed out two main types of waste, as judged from the standpoint of the wants of man. The first is waste in the production of filth, as exemplified by certain patent medicines. The second is the waste of human idleness. Now we come to the third and last great classification, waste in the technical process itself. Thus, an electric light company may be engaged in the altogether excellent objective of manufacturing light, heat, and power for the people of a given city, but it may be hauling coal 1,000 miles to burn it inefficiently under boilers, filling the city with soot and dirt, when coal distillation at the pit mouth, with high-tension transmission lines, or nearby water power, would furnish the needed wants at a fraction of the present cost. Here the student of waste enters a vast field indeed. The question of what constitutes the best technical method of supplying man's wants is a never-ending one. It ceases only when invention and scientific research cease. Machinery 100% efficient today may be worth so much scrap metal tomorrow. The only possible course to pursue under the circumstances is to take the most approved technical process as a standard and measure the gap between it and the process actually in use, after making due allowance for the unproductive labor and materials needed to scrap or adjust the old, and to erect the new. Only when it is clear that more can be gained in output by the new method than will be lost in the cost of adjustment, does the old method stand condemned as a wasteful one. This same line of reasoning would seem to apply to the economic justification of introducing all future improvements in technical processes. Measurements in this field may be approached from two angles. First, what can be saved by rearrangement and a rerouting of the production flow in the existing plant, including both the productive and distributive mechanism, without embarking to an appreciable extent on new construction. This problem was tackled by the Fuel Administration. Second, what can be saved by a complete reconstruction of plant in line with the present state of the technical arts. This was the problem of the Emergency Fleet Corporation. Thus it is possible to contemplate, and perhaps to measure roughly, the saving that might accrue to the people of the United States if the existing plant were utilized solely to satisfy the wants of man. Or it is possible to contemplate, but probably impossible to measure, the saving which might accrue if the existing plant were drastically reorganized in line with modern scientific knowledge, if water power and coal distillation were developed as they might be, if beehive ovens in the coking of steel were replaced by byproduct ovens, if the chaos of retail distribution was scrapped in the interest of properly located warehouses and sample stores, if the pressure of skyscrapers and subways on city populations were removed, if farming and fertilizing processes were coordinated and revised, if scientific forestry replaced timber mining, if natural gas were conserved instead of blown off into the air by the billions of cubic feet, in short, if mankind were intelligent enough to use the vast potentialities of his existing improved knowledge to satisfy his own wants. No consideration of this fascinating field is tenable, it must be repeated, without a realization of the immense construction cost, measured in labor energy and materials, of a transition period. It is in the field of applied technical knowledge that businessmen and engineers have recently been giving marked consideration to the question of waste. Each industry presents a host of problems, in both its production and distribution aspects. In addition, the whole question of a proper coordination between industries demands attention. Modern economic processes are so interlocked and so interrelated that it is practically impossible to set off one industry by itself and study its performance as a separate unit. There is no industry which does not cut across the field of other industries, either in respect to its raw materials, its sources of power, its transportation facilities, its distribution, and its markets. Some day, perhaps, the super-engineering staff will come to build a high central tower from which not only coal problems, but all industrial problems can be surveyed and measured, and intelligent plans laid for the production of human wants, on the basis of a minimum of friction and waste. That such a staff did actually function in England during the war, though its aims were not the aims which concern us here, gives us hope that the proposal does not lie outside the administration capacity of the human mind. End of section 15.